Hello everyone, my name is Eric Peregrina and my research is on the topic of robotics. I have been developing a low-cost 3D printed robot with my mentor, Dr. Andy Zhang. We have advanced robotics to the point where they are being used in other fields of industry. They assist surgeons in complex surgeries, they are launched to other planets to explore its environments, and they can be found underwater collecting fish specimens for marine biologists. The goal of the research is to create a modular and affordable robot. The method was to take two previous robotic designs and merge them together in order to create this first prototype. There were a handful of modifications and redesigns in order to have both designs fit each other a little better. The original rover design had its overall shape and size increased in order to accommodate the arm and other electrical components. Meanwhile, the arm had several modifications in order to allow it to move a little more efficiently. Here is an image of the prototype that has been completed. The rover is 11 inches long by 8 inches wide and has a height of 1 foot. The holes located on the body are hole mounts to attach different sensors or accessories. This prototype will be used for initial testing and determining where improvements can be made. Here is a schematic of the electrical components of the prototype. The robot will include two different motor controllers to control the top portion and bottom portion of the robot. To prevent the battery from draining and any other type of power spike, a relay module will be used to switch the power from the arm to the rover at a push of a button. There will be a total of 8 motors to control the whole robot. For testing purposes, direct analog connections will be used, and at a later time, wireless control will be implemented. This unique board has two on-board motor controllers. This allows multiple motors to be connected at the same time. It works with a minimum of 5 volts, which is perfect for testing. Specifically, this motor shield can control 4 DC motors or 2 stepper motors and several servo motors. This motor shield controls the arm and hand portion of the robot. This motor controller is great for DC motor control. It functions with a minimum of 5 volts, which is good for testing. It includes an onboard speed controller which can be programmed with an encoder to ensure that both motors will run at the same time. This motor controller will control the bottom portion of the rover, which allows movement. Here is a sample of the prototype code that allows basic analog control and basic motor movement. The left picture is the joystick activation and feedback. Meanwhile, the right picture is the analog application where various if statements are used to execute movement when event conditions are met. Currently, the 3D printers are unavailable, so focus was shifted in testing the electrical and programming aspects of the robot. Until the physical prototype can be printed, then physical testing is greatly limited. Program tests were smooth and the outcome were basic commands being executed by analog control. The electrical portion had satisfying results, but motor control via motor controllers can be greatly improved. Until the 3D printers are available again, mechanical movement will be greatly restricted and other aspects will remain untested and improvements will not be made. Some of the electrical components can be programmed for greater motor efficiency or replaced entirely if the results are not satisfactory. The programming is still at an early stage and has yet to include wireless communication.